right, moving on to section 6, arithmetic sequences and function patterns. So our tip here is to always find the common difference first, and our explicit formula is it says a question mark, but it's actually an is equal to a1 plus n minus 1 times d, d being our common difference, n being the nth term, and a1 and an representing the actual number of that term. So a1 is like the value of the first term, an is the value of the nth term. And that's the explicit formula. So let me turn the page. 41. Find the common difference for 5, 8, 11, and 14. Our common difference is just our difference between each of these numbers here. So between 5 and 8, that's adding 3. Between 8 and 11, adding 3. 11 and 14, that's adding 3. So means our common difference is a positive 3. We're always going to read from left to right, because that does make a difference there, because we're adding 3 each time from left to right, because our number keeps increasing. So that's our common difference. 42 is using 41. We're going to write an explicit formula for the sequence above. So we're going to bring down our common difference of 3. And we also need our first term. Our first term is 5, since that is the first one that it showed us. So I'm going to say a1 is equal to 5. And that is all we need now. So I'm going to scroll on past it. So explicit formula is an equals a1 plus n minus 1 times our common difference. So an is equal to 5 plus n minus 1 times our common difference of 3. Typically, we do reduce this and solve for an. Well, an's already solved for, but we want to simplify the right side. So I'm going to distribute that 3. So an is equal to 5 plus 3 times n, 3n, 3 times negative 1, minus 3. And when we combine like terms, we're going to get 3n plus 2. (43) is using part of 42 again. So find a15 for the sequence above. That means the 15th term. So how we do that is we take the formula we just solved for and we plug in 15 into n. So a of 15 is equal to 3 times 15 plus 2. So a15 equals 45 plus 2. A15 is equal to 47. So that is the 47th, or sorry, 47 is the 15th term of the sequence. Now 44 is asking us to write both recursive and explicit formulas for the sequence. So our first step, as always, is to find our common difference. So 20 to 16, that's a minus 4. 16 to 12, that's minus 4. So the 8 is minus 4. So our common difference is negative 4. And then our a1 is 20. Let us do the recursive first. Recursive, we didn't write out that formula here, but the recursive formula, so recursive, is an is equal to an minus 1 plus d. And then it also says what a1 is equal to. So an is equal to an minus 1 plus our common difference, which is actually a negative number. So that gets overridden as a minus 4, and then we call out our A1 value of 20, and that is our recursive formula answer. So recursive is this here. And now I'm moving on to explicit. Our explicit formula is going to be AN equals A1 plus N minus 1 times D. So AN is equal to 20 plus N minus 1 times negative 4. So I'm going to simplify. We have negative 4n because we need to distribute negative 4 onto each term here. Negative 1 times negative 4, positive 4. So our AN is equal to negative 4n plus 24. So our explicit formula, did it again, is that. All right. Our next problem is determine if the sequence is arithmetic. And it gives us a sequence, and we have to explain. So arithmetic has a constant common difference between each consecutive term. So has a constant common difference between each consecutive term. And constant, meaning that between 2 and 5, right, that's a 3. 5 and 9, that's a 4. 9 and 14, that's a 5. Are 3, 4, and 5 constant numbers? Like, are they all constant? Are they the same? Sorry, they're the same. No. 3, 4, and 5, that keeps increasing. And a common difference would have to mean it's the same difference between each number. So based off of that definition, this is a no. The constant, the differences are not the same. So not arithmetic. All right. So 46 is what is the equation of the trend line in the scatter plot? So here's our scatter plot. So this is a throwback to our slope section because in order for us to know the equation of a line, we need to understand our slope. So it's highlighting these 2 points, right? It says use the 2 points to write the equation in slope-intercept form. Write any coefficients as integers, proper fractions, or improper fractions in simplest form. So let's start. So first I'm going to call out these coordinates here. This little blue point is 4, 6. And I know that because I'm looking at the x and y values here that I just circled. And then this second point here is 6, 3. So I'm going to label these x1, y1, x2, y2. And when in doubt, in terms of what to do slope. We have enough information to do slope, so let's solve for it. So our slope equals y2 minus y1, or x2 minus x1, which is, our y2 is going to be 3, our y1 is going to be 6, so 3 minus 6 over x2, which is 6, minus x1, which is 4. So it looks like our slope is negative 3 over 2. So that's our slope. And now we need to use point slope to write an equation, which is y minus y1 equals m times x minus x2. 1. So y minus 6 equals negative 3 over 2 times x minus 4. And we distribute and solve for y. So y minus 6 is equal to negative 3 over 2x. Negative 3 over 2 times a negative 4 is going to be a positive 6. You can either type this in your calculator, you can do mental math, whichever works for you. And now we're going to add 6 to both sides so that we can get this y by itself. So we're using our inverse operations, minus 6, so that's why we're adding. When I say both sides, I once again mean both sides of the equal sign to keep it balanced. Because if you do one thing to one side, you have to do it to the other. So we're going to have y equals negative 3 over 2x plus 12. And that is our equation of that trend line.